Hello, 8 Purple. Today we're going to start a new chapter. It's our last chapter of the year, and it's going to be about patterns that result from the moon's revolution around our planet, around Earth. So, before we begin, I want to talk about perspectives because that's kind of what this entire chapter is all about. So, for example, let's do a quick little riddle. Let's say you have this shadow here that's cast on a wall. What object would produce the shadow? You might say it's something like a square or a cube, and you would be right. Let's say you have a second shadow, and that shadow is a circle. What object would produce that shadow? And you might say a sphere or a circle or something along those lines, or a disk, and you would be right there. But what object would produce both shadows at the same time? If we had a light coming from this angle here, and it created a square, and you had a light coming from this angle over here, and it produced a circle, what possible object could there be that would produce both shadows at the same time? Well, the answer is a cylinder because it has elements of both different objects, right? So it has this kind of right angle here and it has this rounded edge over here. So when you get just one perspective, this one or this one, you might be led to believe that it's not the right answer. But when you get multiple perspectives, that always helps with figuring out more information, and you can get to a deeper truth, if you will. This is a neat little perspective one as well. Some of you may first see an old lady, and some of you might see a young woman. So it's kind of hard to figure out which is which, but you can switch back pretty quickly if you spend some time looking at it. So just to give you a couple clues, if you're looking for the young woman, she is kind of facing away from us, and this is her eyelash right here. This is her ear, and this is the bottom of her jawline. This is her cheek, and then it comes up, and you see her cheekbone right about here. For the old lady, for the old woman, it's kind of she's looking at us. So this is one of her eyes, this is another eye, and this is her nose. It's kind of a little bit large. That's her nose, and then her mouth is slightly agape right there, and she's got a big kind of chin coming out like that. And this is like a hair covering of some sorts. So it's kind of interesting how you can switch perspectives between those two things. So a little bit more in terms of astronomy, from Earth's perspective, the sun and the moon appear to be about the same size, and this is a really cool kind of cosmic coincidence. The sun's diameter is about 400 times larger than the moon's diameter, but it just so happens that the sun is about 400 times farther away, and so because of that coincidence, they appear to be just about the same size in the sky. And that has some implications for eclipses, but we'll get into that detail later on. All right, so let's get down to business. We're going to start off this whole chapter with what causes moon phases. This might be a bit of a review for some of you from fourth grade, but that's okay. That was a while ago, and we can take it slow here anyway. All right, so what causes moon phases? If you're looking at the Earth sun moon geometry from far away, I mean, this is obviously not to scale, but if you're looking at it from far away, you would see something like this, where you have the sun on one side and you have these two spheres over here, and only half of them seem to be lit up from us, right? So this side is lit up from the sun and this side is in complete darkness. This would be daytime and that would be nighttime, and as the Earth rotates, you rotate into nighttime and back into daytime. Same thing with the moon, only one side of it will be lit up from the sun. So moonlight is really just reflected sunlight. There's not much more to it than that. This is just the sunlight coming here and bouncing off of the moon and then going somewhere else. Depending on the position of the moon as it revolves around the Earth, a different amount of that light will reflect towards us. So when the sunlight hits the moon, it sometimes bounces straight back, it bounces off at this angle, it bounces like that. The one thing it doesn't do is curve around the backside. But if you're here on Earth and you're looking at the moon over here, you would see a large portion of it in black. So you would see this half of the moon and the side of the moon that's facing Earth. And most of that moon is not getting sunlight. So you would see a dark shape over there. You would be able to see the moon if you had like extremely good vision, but most of it would be dark. And only a small little bit of it would be some sunlight that's reflected back towards us. So this would cause that moon to appear kind of small because it's not that much light being reflected towards us. But as the moon orbits, as it moves its position, it gets to a point where more of that reflected sunlight is reflecting towards Earth, and we kind of get in the way of that reflection, and so the moon appears to have grown in size, when in fact it hasn't grown at all. We're just being able to see more of it because it's coming along the backside of Earth. That concept of reflected light is called albedo. And an albedo is the amount of light reflected by a surface. So you can look at this diagram. There's a couple of really neat things here. Grass, for example, or we'll start with snow. Snow reflects about 80 to 95% of sunlight, and that makes sense. A lot of times you need sunglasses when it's snowing out. It can be really blinding. Grass actually reflects a good amount, almost a third or a quarter of the sunlight that hits it. It gets bounced back. No surprise with blacktop or asphalt, that absorbs quite a bit. It's not very bright, 5 to 10%. Um, a light roof kind of reflects a lot. And then water bodies, well, they change drastically with the sun's altitude. The moon, take a minute, guess what albedo you think the moon reflects. Turns out it's only about 6 to 8%. It's not a lot at all. It's along the same as blacktop. It reflects the same amount of light as a road surface or a parking lot. And I guess that's a good thing, because if the moon reflected a tremendous amount of light, like as much as water did, then it would be incredibly bright whenever there's a full moon. It'd be like a second sun was rising, and it would cause like havoc. I don't know how we would even deal with that. All right, so moon phases. The phases of the moon depend on its position in relation to the sun and the earth. As the moon makes its way around Earth, it reflects more or less sunlight, and that's called phases. So here is, I guess, let's see, am I using this for anything? No, I don't need that. So as the moon makes its way around, more or less of the light is going to be reflected back towards us. There are well, let's go over this. There's 4 main phases. These you should be totally familiar with. The new moon reflects no light towards Earth, so that's going to be where it doesn't mean the moon isn't reflecting light. It just means that none of the reflected light is going in the Earth's direction. The first quarter is when we can see the right half reflected towards us. The full moon is when the moon is on the back side of the planet, and it's reflecting all of its light back towards Earth. And then the last quarter is when the left half reflects light towards Earth. In between these 4 main phases, the moon has to change. It has to transition from one phase to the next. So those changing phases are called waxing and waning. When the moon is waxing, that means that the amount of light reflected is increasing. So from a new moon to a first quarter, as there's no light, and then that increases to half, and then that increases to all of its reflected sunlight, that would be considered waxing. And then when it reverses course, well, it's not like the moon changes, but changes its course. But when it starts decreasing the amount of light reflected towards us, that would be called waning. So going from a full moon to a last quarter, and then back to a new moon, as that light diminishes, as that reflected light is no longer hitting Earth's direction, that would be waning. Depending on the percentage of the light reflected towards us, it will either make the shape of a crescent, which is like a sliver, which is your cartoon looking moon, or when it gets past a quarter moon, it would become a gibbous. So when more than 50% of the moon is illuminated that we see, that would be called gibbous. So the moon can be described as any one of these 4 phases, or any combination of the changing phase and the shape. So like a waxing crescent, a waxing gibbous, a waning crescent, or a waning gibbous. All right, so here is your task for today. This is going to be your exit ticket. I'm going to present this diagram on the exit ticket, and it's your job to figure out what is underneath these labels. So, for example, the yellow ones, those are going to be your 4 main phases. So which one is which? And then the gray ones are going to be your transition phases. So you've got to figure out which one is crescent, which one is gibbous, which one's waxing, and which one is waning. As a big part of this diagram, though, is that it's totally dependent. It's relative on where the sun is. So because the sun is down here, that's going to tell you exactly what phase this is going to be. And I'll give you a hint. I'm going to start this one off. This is the new moon. So when the moon is here, the moon is in this position, it'd be considered a new moon. The other thing to know is that the moon, when viewed from above, goes counterclockwise around. So you're going to probably be able to figure out B, C, and D fairly easily, but the challenge might be figuring out what goes underneath these gray things. It's going to be one of these 4 words, right? So you'll use each of these words, but only once. So waxing, waning, crescent, and gibbous, those are going to fall under one of these gray things each. Okay, so that is that's a challenge for you guys. Go ahead and move on to the exit ticket and submit that when you're done with it. Thank you for watching.